So, ladies and gentlemen, can I say first of all, thank you Morrisons for inviting me. And I have to admit, yesterday to Sophie, I only went into Morrisons for the first time yesterday, because sadly, Morrisons don't exist on the island of Ireland, and maybe someday you will put an old man, put it all aside, and come and visit them. So, I want to give you a slightly different perspective. I myself am a farmer. I have my own farm. I'm a fifth-generation farmer. My son and daughter-in-law home running the farm. I'm also an award-winning farmer. I've won a lot of awards in the Irish Farmers Journal. I've been a finalist in the Farmers Weekly as well. And I also was president of the Ulster Farmers Union just in time for foot and mouth. So if you want a baptism of fire as a farm leader, take on foot and mouth. So I learned a lot during that period of time, I have to say. Today I want to reflect on the privilege I was given in 2013. Up until then, not only had I been a farmer and farm leader, I had for 7 years chaired DEFRA's Rural Climate Change Forum, which most of you probably never heard of. It did exist between 2005 and 2012. It was a multi-stakeholder group directly answering to Margaret Beckett and Hilary Benn about climate change, farming, food and forestry, and how could the sector engage. And my role was to bring a practical view of that. So I want to share my experiences as a practitioner, because one of the nervousness I had, and you heard me asking a question to Michael Lee earlier on, is there are a lot of people talking at farmers, not talking with farmers. And there's a real subtlety about this, because actually I and all you as farmers and our peers need to go on this journey as well. So, which am I pressing the right button? Okay. So the first thing I want to do is lay out my vision of what does net zero mean to me on my farm or the Devenish Research Farm in the lands of Dowth. Well, I give this definition in 3 steps. Now, some of this is repetitive, but there are issues I just want to label. First of all, gross emissions. Gross emissions in my farm is where I add up all the CO2 emissions from my vehicles, my tractors, my heating of buildings. My methane from belching in my stock, from my manures, and my nitrous oxide, particularly from wet soils. And in Ireland, we have a lot of wet soils, okay? Currently, that is what our sector is reported on, okay? And actually the reason the Rural Climate Change Forum came to an end is DEFRA and I had an on-pass in 2012 that said, that is all you can measure this industry against. Now I know, and you know, that our landscape are full of plants that photosynthesize, that lock up carbon and release oxygen. Okay, cattle, sheep come along, they eat it, they re-release some of it. But if I do my job right, I can build up more carbon. So that total of locking up carbon is my gross sequestration. Currently, it is not measured. Currently, it is not reported in the Greenhouse Gas National Inventory, to which this government has to report against. Interestingly, last September, the Intergovernmental Panel on Climate Change said that if net zero is to be achieved by 2050, we need to increase the amount of carbon stocks on our farmland as well as reduce emissions. It's just really sad yet that policy has yet to build it in and recognise it. Now, I was reassured the UK's Climate Change Committee has also recognised that, but again, policy in the United Kingdom does not recognise it at the moment. So for me, on my farm, net farm carbon is what I really want to talk about. And that is the sum of my emissions, the sum of my sequestration, and net zero is where the two end up equaling each other. It is not about getting an advantage. It's about being smart and reducing my emissions, increasing my sequestration. And the real question is it achievable and how do you do it? And I was afforded in 2013, Devenish, and who are Devenish? They are a livestock nutrition and research company based in Belfast, bought a farm and said, we're going to have a go at it. Because it's one thing modelling it, it's another thing as a practitioner to go and do it. So in 2013, we bought 185 hectares just north of Dublin in County Meath, a place called Dowth, and predominantly grassland with some woodland, with some floodplains. And really what we decided to do, and you've heard it several times today, is take a systems-based approach. I did like the tunnel vision of carbon, I have to say, because actually that's where a lot of people are. But I make no apologies. My background, I was an arable farmer, then I went in and grew willows, I was a renewable energy farmer, I knew nothing about livestock. And my chairman was mad enough to employ me and said, I want you to do this. So I made no bones, I started with soils, because we have on the statute that from soil to society, you don't get your soils right, you don't get your sward right, you don't get your sward right, you don't get your animal right. If you don't get your animal right, you don't get humans right. And that's Michael's really focused on. But one of the key things I wanted to crack is, could you at a landscape scale measure carbon stocks? And if you could, if you continue to repeat it every 5 years, could you measure change? Additionality or not? And I wanted to focus on that. And in trying to crack that, could we get other benefits? And particularly in Ireland, we have a water quality problem. And nitrates is easy. Ours is phosphates. Okay? Phosphates are really difficult because they hang around in the environment for a very long time. So could we use some of the smart digital technologies to help us reduce the runoff of our farms and improve water quality? If that wasn't enough challenge, we went to look at biodiversity. And remember, there's more biodiversity under the soil than above the soil. So for me, improving biodiversity, it's very simple. It's about increasing earthworms and all the nematodes and everything else that goes on in that soil microbiome. We had an additional problem. We inherited one of Ireland's last lowland herds of wild red deer. And one of the issues about that is it starts to create new dilemmas. And how do you create trade-offs? I want to drive my carbon sequestration of trees, yet I have up to 150 wild red deer who love my trees for all the wrong reasons. So how do you actually put those baselines in and make decisions within the environment? This is a trade-off within the environment, not within the environment within the farms. And lastly, if that wasn't enough, all of the farms are UNESCO World Heritage Site. So whatever you may feel about the Environment Agency, I'll introduce you to National Monument Service. Who in the very first month said to me, by the way, shook my hand, congratulated Devenish bought this farm. And in their next breath said, you can't do this. No, you can't put that new water main there. No, you can't put that drain there. That made it really difficult for me to create a landscape, a ruminant landscape performance house. And so we went on a journey, a really precision journey, a lot of it driven by archaeology, but actually really gave us a real hand to sustainable land management. For our efforts, 5 years ago we were recognised by Wageningen University Research in the Netherlands. None of you might have heard them, but for the last 7 years they've been the #1 university in the world for agriculture and forestry. And we're now one of 12 of their global network of lighthouse farms for the precision that we went on an actual farm. So to do this, to go on this journey, you need to create baselines. You've heard about baselines before. On emissions, well, I want to do baseline about carbon stocks, about biodiversity. So what we did in 2014, in partnership with the School of Archaeology and UCD, because remember I had to get the National Monument Service off my back, is we digitalised the landscape with 3 different surveys. Actually, four of them is mentioned here. The first on the right-hand side is we did a precision soil sampling analysis. What is our situation? Not only in carbon stock, but soil fertility. The second one on the left-hand side is helicopter. And if you look on the helicopter, there are 2 funny discs hanging left and right on that. And that is a technology called LiDAR. So most of you have heard of radar. Radar sends out a radio beam, it bounces off something, it comes back again. LiDAR does the same, but with a laser. And at 40 scans per square meter compared to a satellite at 1 scan per 10 square meters, you get a really accurate footprint of your landscape. If you repeat it every 5 years, you measure change. And the middle technology was about telling us what was underneath the ground. That top metre and a half was our archaeology depth. The consequence of that
is a month after we did the LiDAR data, our Environment Agency in Ireland produced this document measuring carbon sequestration in hedgerows in the Irish landscape using LiDAR. Now that was a coincidence. We didn't plot that. So, lo and behold, that was carried out by Shaggis, who's the Irish Government's Agriculture Advisory Service. I phoned up their chief executive. It's a great report. Why didn't you do a landscape? They said it was too expensive. So I said, well, I'll give you a landscape of data if you give me your technologies. So in 2014, we became the first farm in the world to actually digitally measure every tree and hedge on the farm. And what you can see in this orange table there, in our biomass density in tons of carbon per hectare, we've 83 tons in our woodlands per hectare, and we've 127 tons per hectare in our hedges. I didn't see that coming. Why is that? Well, actually, if you think about it, you can walk through a woodland, you can't walk through a hedge. A hedge is far more dense because it's meant to be stalk through. The flip side of that is you need many kilometres of hedges to give you a hectare of woodlands. Okay, so that's the flip side. But for the first time, we were putting measurements, hard measurements about my farm, not my neighbour's farm, and all things that were in my control. We then went and measured our soil carbon. We weren't as luxurious as Hugh with his fancy kit. We went and did it the old way, is we went and dug with soil pits. And we randomised it. We did 88 soil pits, marked them with GPS, and measured our soil carbon. What we knew is our land had to be applied for 40 years. Some of it longer. We had a lovely brown earth, medium loam. What we weren't expecting is our soil carbon was rubbish. We didn't see that. Didn't see it coming. The literature did not talk about that. So what is going on? Okay, what is going on? And this really goes to the issue about management over land use. So when we did all that, we found, we topped that up and we used Tier 1 sequestration factors from published peer review. We worked out on an annual basis, we roughly sequester 665 tonnes of new carbon every year in our farm. I have given a commitment to the board of Devenish that we will be carbon neutral by 2025. So the challenge for me is, how do we do it? Now I could do the easy one, which is what the media, a lot of the media are saying, is get rid of livestock animals. Okay, so what I've done here is I've done a sensitivity analysis on stocking density. So forgetting about everything else, if I just changed my animals, what would happen on my farm? So up the y-axis, you've got total greenhouse gas emissions annually at dowth. Along the x-axis, I've got livestock stocking density. So 1 livestock unit per hectare up to 2.5 livestock units per hectare. The whole of the island environment is a nitrate vulnerable zone. So we're capped at that, we can't go any further. So really what I'm saying, at 1 livestock unit per hectare, I can have 91 cows, whose gross emission is 580 tonnes, but I know I sequester 665 tonnes. So at 1 livestock unit per hectare, we are already beyond net zero today at -76. If I go the opposite way, if I'm a dairy farmer, 2.5 livestock units per hectare, I have 228 cows, grossing 1,450 tonnes. Less my 665 give me a net position of 795 tonnes. We're actually 2 livestock units, we're what we call a non-derogated farm in Ireland. So 182 cows, grossing 1,161, less our 665 or sequestration, our net position is 496 tonnes. So at 2 livestock units per hectare, we are displacing 56% of all the greenhouse gas emissions. So if I only look at destocking, my sweet spot is 1.25 livestock units per hectare, is where that net emissions cuts the x-axis. But that doesn't feed the world. And so for us as a research company, we've been focusing on what is it, the 2 livestock units per hectare we can do to get our footprint down. And not only to net zero, but can we go beyond net zero? Because remember, net zero is not about every farm getting to net zero. Net farm is about the average of the industry getting to net zero. Which means some farms will never get there, and some farms will actually really get onto it and be very good. And that's where I believe we need a trading scheme between farmers as such, rather than outside the sector. So really we want to focus. Now, I'm going to take as read, and I know Ralph is going to speak to us. The work they're doing in animal health is stunning. Genetics, livestock efficiency is absolutely the first place to start. But I'm going to show you 3 other ways that we're also looking at. I'm going to go back to the soils. Because actually, when we did our baseline of soil fertility, we found one glaring issue, very simple issue, is most livestock farmers for the last 40 years have forgotten about a little 4-letter word called lime. Most farmers, not arable farmers, but livestock farmers have forgotten to put lime on. Our pH was rubbish. And by the way, your soil carbon is biological, it sits in the microbiome. The speed that the microbiome actually refreshes itself is pH sensitive. So if your pH drops, your microbiome slows down, and your carbon stocks reflect that. So our first program is correct our soil pH. Absolutely fundamental, and we're already seeing our soil carbon beginning to rise. The second thing, and Michael touched on this, is bringing sward diversity back onto the farm. So traditionally in Ireland, our livestock industry, perennial ryegrass and synthetic nitrogen. And we're bloody good at it. We can do a lot of grass, okay? But our footprint is awful. And so what we did is we secured funding from Brussels. We tied up with Wageningen University, University College Dublin, and we created the first large-scale grazing trial of beef and lamb, 36 hectares, broken down into 4 sward diversities, permanent pasture, perennial ryegrass, 6 species, so 2 grasses, 2 herbs, 2 legumes, 12 species, so 3 grasses, 4 legumes, 5 herbs. And we designated beef, dairy cross, heifers, and ewes and lambs onto each one. Whichever designation you got, you stayed on, and you were slaughtered off that. We looked at the soils, we looked at the swards, we looked at the animals, and we currently are looking at the micronutrient content of the meat. Hence Michael's comment. What I will flag up is in the very first year we reduced nitrogen on our perennial soil, on our permanent pasture by 65%. As an average, our average daily weight gain increased by 20% in the multi-species. To give you the exact figure, beef by 17% and lamb by 37%. Our lambs are going to slaughter 42 days earlier on the multi-species than on perennial ryegrass. And we're using no anthelmintics on the multi-species. And last year we had to use 3 runs on the perennial ryegrass. 300% increase in earthworms. So first key indicator in biodiversity, really stunning. Water infiltration 14 times faster. Really important to stop that runoff. And when we put that through our life cycle assessment calculator, in our case, AgriCalc, we reduced the greenhouse gas emissions per kilo of output by 26% in 1 year, while delivering those multiple public goods. And that came from a 60% saving in nitrous oxide and a 40% saving in methane. The last area I'm going to flag up, it's not actually our work, it's actually through the Agri-Food and Bioscience Institute in Northern Ireland. The longest trials of silver pasture in Europe for livestock and trees grazing is in County Armagh, a place called Loch Gull. They have 32 years of data there now. This is a summary of 30 years data. They first of all looked at the increased carbon stocks over 30 years. And what they found in silver pasture, which was ash and perennial ryegrass, they had a 2.4 tonne per hectare per year increase in carbon as an average over those 30 years. On perennial ryegrass, it was 0.6, I don't know where the 1.2 came from. So it was 0.6 against the standard forest practice in Ireland, sitka spruce, at 3.8, which of course doesn't do anything for food production. If you look at their biodiversity benefits, in each case, the silver pasture won spiders and birds and beetles. But most interestingly for me as a practicing farmer, the cheapest kilo of beef or lamb or litre of milk I can produce is from grazed grass, then from ensile grass, then from bought-in feed. Our problem in Ireland, and there are many places in England, Scotland, and Wales the same, is we can grow a lot of herbage. We can't utilise a lot of herbage because of soil trafficability. It gets too wet. And one of the key things they've found here is they've been able to extend soil trafficability by 17 weeks a year. Now that's a game changer about keeping animals outside and actually optimizing your profit by utilizing more of your grass. The other thing I'm going to flag up, I haven't got here, is what we're doing on my own farm a week ago with Professor Sharon Hughes, who's sitting over there, from Queen's University. We've now actually started a trial of grazing our willow trees with cattle to see can we increase methane reduction and also drive carbon sequestration. So really trying to push the boundary out and finding practical solutions. But when you use these kind of technologies, this image is our image of dowth. Each colour is an individual watershed on our farm, and the red blood vessels that you see there are the places during extreme rainfall that our water runs off our land. The reason this is very important, if we want to improve water quality, you actually need to know where does the water run, where does it come from, and can you prioritise that? And when you do that, lo and behold, you find like the standard riparian strips parallel to a water course, 80% of them in the wrong place. So this is about science-led decision making on your individual farms. And from that we can prioritise an area of fertilised degree of slope, so we can risk rank each watershed on our farm. So we've taken all this data and we've tried to leverage it. Okay, so we've done it on one farm. Can we do it on more? So we were very privileged. We secured funding from EIP Agri and the North Ireland Executive through our Department of Agriculture, Environment and Rural Affairs. We said, could we leverage it into another collection of farms? So 7 farms looking at gross emissions, gross sequestration, net carbon, soil fertility, runoff risk maps, partners like AFBI, AgriSearch, Devenish, Queen's University and SRUC. And really what we wanted to focus was not only emissions but carbon stocks. These 7 farms, we had 10 years historic data. We really want to know, because the literature doesn't tell us, when you know your carbon stocks, what is it that can give you more carbon? We have a knowledge gap there. So what we did is, the one thing we learned in dowth, that if you know the history for the last 10 years, you can go backwards and get an understanding. So we categorized, we broke each farm down into 2 hectares, and we asked, of each 2 hectares, what was its soil organic matter level? What was it used for? Grass, arable, woodland, we went into all the woodland areas. Was there organic manures applied? Was it slurry? Was it farmyard manure? Was it compost? If it's grassland, is it permanent, rotational? Is it cut? Is it cut and grazed? Or is it grazed below? So what is the role of the grazing animal in soil carbon? If it's rotational grass, is it predominantly perennial ryegrass or multi-species? And if it's woodland, is it deciduous, coniferous, short rotation willow, or agroforestry? So we've 1,000 hectares in this, we've got 502 hectare blocks, we've 85 land categories, and we went out and sampled carbon against those categories to really answer. So I'm going to give you one example. Ian McLeod is a dairy farmer, he's 88 cows on 60 hectares, so really quite typical size in Ireland. And really what we wanted to do is, you can see all the categories we've tested. You can see his acreage, you can see his soil organic matter, his soil carbon 10 centimetres, his soil carbon 30 centimetres, and you can see your soil texture classification. Remember, clay was flagged up, really important. So we can do all that. But when you do that, things start to emerge. Now, we haven't got enough acreage through here to say that this is definitive. Okay, so that's the health warning. But what are we seeing? Is, lo and behold, fields that always have animals grazing and not having the grass cut off, even though they've got the same soil texture classification, have higher carbon. The role of the ruminant in inoculating the microbiome in the soil. The microbiome in the soil is nearly a mirror image to the microbiome in the rumen. Huge, and Michael touched on this, the role of the grazing animal. And when we added all that up, because we want transparency, we want to empower farmers. So on Ian's farm, he has 6,630 odd tonnes in the top 30 centimetres of the soils. He's got another 254 tonnes in his trees and hedges. So his total carbon stocks is 6,885. If I multiply that up That is just over 25,000 tonnes of greenhouse gas emissions that he manages. So when I get stopped by a friendly vegan and I get criticised, I say in Ian, on my own farm, I'm sitting about 52,000 tonnes. I manage 52,000 tonnes of carbon dioxide every year. How much do you manage? You know something, it's the quickest way of silencing your critics. And what we're trying to do is bring transparency to our journey, okay? And turn the public narrative. So we've done that then on his greenhouse gas emissions. In his case, we've looked at gross emissions, we've benchmarked them, we've looked at the sequestration, looked at his net emissions. So on his dairy farm, his net emissions are 27% below his gross emissions. So we've taken all of this and we've embedded it. For the last 7 years, I have chaired the Northern Ireland Government's Expert Working Group on Sustainable Land Management Strategy. So we've embedded that. We've done 3 catchment pilots, got 80% farmers engaged. After 18 months, 80% behavioural change. We went back to the government, and as of March of this year, Northern Ireland is the first place in the world to have one framework, a Northern Ireland Soil Nutrient Health and LIDAR scheme. It's a £45 million investment into Northern Ireland agriculture from government, and it's about baselining every single field, every single tree, every single hedge, and it will be repeated every 5 years. So we will have true transparency. And for me, someone asked the question earlier on, should we not be looking to bring all of this together? The answer is absolutely yes. And for me, I actually do think government, and I am critical of government in London, walking away. Government does have a role, and that's about looking at the standards, the governance around the vehicle that we go forward. I'm very privileged that in Northern Ireland we have a government who's faced their responsibilities, found the cash, and is taking us on a journey to create this vehicle. So just my last slide, if you want to know more, our multi-species sward is called the Heartland. Our Zero project is there too. If you want to know more, you're very welcome. And as Sophie already knows, we are quite hospitable in Ireland. If you can get out your passports and get over that Northern Ireland protocol, come and see us and come and see it for yourself. I hope I've shared a practitioner's view of how we go to net zero and what it means to us on individual farms. I'm not a modeler, I'm not a researcher, but I'm passionate about this industry. Thank you.
Thank you so much, very inspiring indeed. Has anybody got any questions that they would like to ask John whilst he's here? Oh,
just
go for it, Graham. Yes.
I'm about to speak at the moment, but I was trained as a soil scientist and a forester. And what has never ceased to amaze me is how much ignorance there is in the forestry sector about soils. This fundamental thing. And kind of what you've been pointing to is actually still got an awful lot to do on agricultural soils.
Can I come back to that? Because I love a conversation afterwards.
Yes.
Because in Arc Zero we went into all our wooded areas. And we found something that scared us. Yeah. And that is, under woodlands we've forgotten about soils.
Yeah.
And we have seen a complete collapse of soil carbon on the trees, which we didn't see coming. And the simple issue, pH. pH. Foresters don't put lime on their land.
No, and actually there's a whole load of natural acidification in it, wasn't it? But that's still also pollution.
Excellent. Well, these two talks are leading very nicely into each other without me having to do a thing. So thank you so much again, John, and I know you're with us a bit longer, so I do appreciate your time.